Now we're going to move into the next section. I don't think we'll go quite as long here, but we're going to be talking about a really important package called ggplot2. This is a part of the TidyVerse core set. So if you load TidyVerse up, you're going to get ggplot2 along for the ride, and we'll show you how powerful this is. Hopefully this, I'm going to be going maybe in and out of RStudio a little bit. So hopefully it's big enough to see. It's a little easier for me to interact here with the Zoom interface if I'm in the non-presentation mode. But if anybody has a problem, let me know. Okay, so goals for this module. We're going to briefly talk about this idea of the grammar of graphics, or at least sort of some of the underpinnings, ideas, philosophies that ggplot2 embodies, and how it maybe differs from the ways in which other kinds of programs allow you to do data visualization. And in particular, I like to say ggplot2 lets you become a data visualization chef. And we contrast that with maybe a data viz customer or a patron or something, somebody that would come into a restaurant and order food off of a menu. That's kind of like one style that visualization programs let you make plots with. ggplot2 is different. It essentially lets you become the chef, the person behind the scenes that can actually sort of make any kind of thing they want. Particularly, we're going to be talking about the ggplot2 package, as I mentioned, and then we're going to learn some essential syntax for ggplot2, so you can start making some basic plots yourself in R. Just a few notes. ggplot2 is really, it's a deep package. There's a lot there. It's quite complex. It's been around for quite a while. It's very stable in terms of the package, but also has a ton of functionality there that you can really dig into if you want to make some really interesting, unique plots. But it's very deep. This is just very much an introduction. It's just scratching the surface. It's not complete by any means. So please don't think that this covers everything that's there. That being said, at the end, I'll give you some resources that you can take a look at, that you can hopefully look to and continue on your journey of learning ggplot2. This third point here, I think it's really important. In base R, sort of standard R, you can make some plots really quite easily using the default plotting functions. There's a plot function where you can give it 2 vectors and it will make a scatter plot. There's a hist, I think, function that makes histograms and so on. And you can do that with like almost very little code. ggplot2 syntax is more complex, requires more code to type. There's lots of parentheses that you have to get right. There are sometimes you put quotes around names and sometimes you don't. And learning all these things, certainly in the very beginning, is a little bit tricky. And I think people that maybe just try to jump into ggplot2 casually might get turned off to this stuff and go back to the old ways of doing things and making plots. But I'd say as an R user, this is another one of the absolute essential packages that's worth learning just because it's so powerful. So like I said, it's not the easiest library to learn, but it's certainly one of the most powerful. And in fact, ggplot2 has influenced, I'd say, data viz and lots of other places as well in terms of how people think about plots in other languages and so on. So this has actually been a really influential package. In fact, lots of people, 10 years ago, lots of people, you talk to people and you ask, how did they get into R? And they said, I got into R because I wanted to learn ggplot2. Like they wanted to learn this whole new programming language just so they can use this one package. It's that powerful and that influential. So ggplot2 is based on the grammar of graphics. There's actually sort of lots of ideas around this in the past. Wilkinson here has a book called The Grammar of Graphics that kind of forms a foundation for this. And then Hedley Wickham, the person I mentioned before, the author of this package, sort of took some of those ideas and wrapped them together in this idea of ggplot2. And effectively, what it allows you to do is build up plots in this layer by layer approach. And you'll see what these layers are when we look at the examples. He has a paper here where he talks about this and sort of the ideas behind ggplot2. Probably worth a read if you're interested. As I mentioned, I like to say that ggplot2 lets you become a chef, a data viz chef. And I want to contrast that with, you go into a restaurant, you're hungry, you go into a restaurant, you get a menu, and you pick from items on the menu that you can order to eat. And this is kind of like Excel. If you've ever done a plot in Excel, actually I haven't made a plot in Excel in a long time, so I don't know exactly what the interface looks like nowadays, but I recall in the past that you would go to like a plot kind of gallery and you'd select from a series of different kinds of plots that you would want, and then it would provide an interface for you to input data, and then a plot would pop out. But the key thing there is you were selecting from a menu of plots that you could do. And if you wanted to do something a little bit different, you really didn't have that flexibility. So in that sense, you're kind of like the data viz customer. You can order what's off the menu, but that's it. ggplot2 is this other ideas that ggplot2 gives you the individual pieces or the ingredients to make any kind of plot that you want. So essentially you're a data viz chef. You take the pieces, the fundamental components from ggplot2 and combine them in different ways. Just like in those dplyr pipelines, we were combining those verbs together in different ways to do data analysis. Kind of have a similar thing with ggplot2 where you can take the individual pieces to make the plot that you want. Let's give a high level view of making a plot in ggplot2, and then we'll dig in more details here. So basically you start with a data set. It should be a tidy data table. Recall that ggplot2 is part of the TidyVerse, and it assumes that your input is going to be a tidy data table. So you start with that. This is that empty cars data set that we have been working with. You write some code here. Here's some ggplot code here, plot2 code. I'll go into the details of this. If you type this and hit return, you'll get a plot that comes out. Okay, so that's the way you work with it. Start with a data set, write some code, out comes a plot. Okay, we're going to dig into these details in just a minute. There are some important concepts of ggplot2. These are not all of the concepts, but these are some of the key ones here. The idea is that we want, effectively when we're making a data visualization, think about it at a really high level. We want to map the values in our data to some kind of visual representation. Okay, we want to make this connection, make our numbers and characters and strings into graphical representations, right? And we have this mapping between our data and those representations. That's really what we're trying to do when we make a data viz. And that's the main goal here. And there's ggplot2 thinks about this in a couple ways. One is this idea of so-called geoms. We're going to look at these geom functions that, like the name implies, geometric items, think of shapes or sort of glyphs, if you will, that represent your data. And so these things can be things like points or lines or bars or pie charts or things like that. So different shapes that are going to represent your data. This other idea uses this kind of strange word, aesthetics, this idea that these are the visual properties of the object. And those can be things like position. So if you have a point, you need to define where that goes. So you need to define its position in the, say, the XY plane, or how big the point is, its size or its color, its shape, all those kinds of things. Those are the visual properties of your plot. And the cool thing about ggplot2 is we can map these visual properties to pieces in our data. Okay, so for example, we could map the size of a point to a given variable in our data, and the data points will vary in size based upon another piece of data in our table, which is really cool. And then the idea is we want to map between these variables that we have in our data, think columns in our tidy data table, to their aesthetic properties in order to make the plot. Okay, there are other things here. There are things about scales and transformations and so on that I'm not talking about explicitly here, but these are some of the main points. Let's see, I'll pause here for a second if there's any thoughts, questions. Okay, let me keep going. Okay, let's talk about ggplot2 code. And again, like I said, the hardest thing about ggplot2 when we start out is, yeah.
Actually, Ryan, there is a question.
Great.
Is there a difference between putting the aesthetics function inside the geom layer versus putting it as an argument to ggplot function?
There is. I'll come to that a little bit towards the end and describe what that is. Yeah, I think I have a slide on that. So please write down your question, whoever asked that. And if I don't answer it, please ping me again. But I have a slide on that here in a little bit. Okay, this is the basic ggplot2 plotting template. Like I said, the syntax is the thing that's going to be the most, I think, difficult thing to deal with in the beginning for new users. But here's the idea. We started ggplot2 object off by calling ggplot. Notice there's no 2 here. Okay, the package is called ggplot2, but when we actually go to make ggplots, we just call the ggplot function. Okay, no 2 there. Just it is what it is. So just don't put a 2 there. ggplot. This says we're going to initialize a ggplot object here, and we need to give it a data table. Again, I've said this over and over again, but functions in the TidyVerse often usually expect that the first argument is going to be the tidy data table that you're working with, and the same thing occurs here, that the ggplot function needs the data table that we're working with. That I'll show you an explicit example here. This is a placeholder here for the data table, and we're going to put an actual data table name here in just a minute. Then we're going to supply a geom function, the kind of visual representation we want to use to represent our data. Here, these geom functions have names like geom point, which you could probably guess is what you'd want to use if you want to make points. You have geom lines, histograms, box plots, and so on. So different ways to represent your data. You can probably guess what these things are by their names, which is nice. Then we have this mapping argument, and it has kind of this complex structure. We have mapping here equals, we have AES. Remember, we came back here. The AES is a short for aesthetics. And again, these are talking about visual properties of the things we want to plot, like the properties of the points. So we have to do a mapping using AES that maps columns in our data table to the different properties. I think it's easier if we just take a look at an example here. So here's the same template now we saw on the previous slide, but now I've replaced it with explicit data here. So we initialize our ggplot object with the mtcars data table that we've been looking at. Now, this in itself, if we were to run this command here, this will give us nothing, okay? Nothing will happen. We won't see a plot, we won't see anything. This just initializes essentially the canvas, if you will, that we're going to be making a plot on. We have to add, using this plus sign here, different geometric representations of our data. And we're going to add on here a point representation using the geom point function. And we're going to do a mapping. This is mapping our aesthetics of the points to columns in our data. Okay, so we use this AES function. The X position is going to be the weight of the car, and the Y position is going to be the horsepower. Okay, if we run this code, we get this plot out. And on the X is the weight, on the Y is the horsepower. We have points because we use the geom point. Whoops. We use the geom point representation, and we have points for each of the cars here. So each point represents a car with horsepower by weight. Okay, let me point out a few important things here. In the dplyr examples, we did not use a plus sign, although it may have logically made sense to use a plus sign. Remember, our pipelines, we use the % sign greater than % sign. In ggplot2, we don't use that. We use plus. Okay, this is saying add a new layer onto our plot. ggplot2 was actually made well before dplyr in the idea of the TidyVerse. And at that point in time, we didn't have that pipeline function. And so Hadley used pluses instead of pipes. I think he wishes, if in hindsight, he could have used that same pipe operator for consistency with dplyr, but it's just a historical kind of thing, and he's not going to update the package to do that. So just know when you write dplyr pipelines, you use the % greater than %. When you use ggplot2, you use plus instead, okay? Let's see, I think that was the main point I wanted to make here. Again, it's the syntax. You have to make sure you get all these little parentheses matched up just right, and these equal signs and so on. That's important for making things work. So any questions about this fundamental template here? You could probably take this template and make a slightly different version of this plot just by changing the column names here. Oh, the other important thing, sorry, I wanted to mention this. We don't quote, and actually I probably say this on this slide here. Well, yeah, a little bit. Okay, so this is a breakdown. If you want to refer to what I just said here, you can look at this slide here. But an important thing here is we don't put quotes around these column names. Okay, it's just the way in which R works. It's one of these things about R. When we, stuff that goes inside the AES sign here, column names are not quoted. Okay. And I made this mistake a lot as a beginner. I put quotes around there. The plot will not look as you expect if that happens, or will error out. So make sure you don't put quotes around the column names inside the AES function. Okay, let's take a look at another thought here is that if you were to look online, say Stack Overflow or at other people's code, you won't necessarily see lots of this stuff here. You'll see things get simplified out. And in particular, in practice, you'll simplify these things further. So usually you won't put data equals. It's additional code. You don't need to do that. Typically, you'll just supply the input data frame. You typically don't say mapping equals because you don't want to type that over and over again. And so you can simplify the code in that way as well. Let's see here. In fact, you could even get rid of the X and Y here to simplify this code even further. That's probably what you'd see in practice if you saw this plot online. The main thing that we're relying on here is that we know that the first arguments of the ggplot call has to be a data frame, and the first argument of the geom function calls needs to be an AES mapping. Okay, as long as you conform to that, you can get rid of the data equals and the mapping equals here. All right, that's just sort of simplifying things a little bit, and probably what you'll see in practice. Let's look at things a little, slightly more complex in terms of the aesthetics. And again, please, these are not beautiful plots by any means, and they're kind of silly. But again, we're just looking for concepts here as opposed to great data visualizations here. We had previously mapped in the aesthetics the X and Y positions of the points. But remember, we have all these other aesthetics we can map as well. So for example, maybe we want to change the shape of the plot based upon the number of cylinders that we have. One note here, cylinder, remember, is a number, 4, 6, and 8. But a shape is a discrete kind of object. It's a categorical object, like a square or a circle or a triangle. So we have to change a number into a categorical kind of variable. We do this with this as.factor. So we need that here to convert this cylinder into a category type. So we can do that with the cylinders. We can map the color, which is a continuous variable. That's okay, to the miles per gallon. And we can make the points a little bit bigger. Let me talk about that in just a second. But look down at our plot here. We have different symbols, different shapes for the number of cylinders that the car has. We have a continuous color gradient that maps miles per gallon. So lighter colors have better miles per gallon than darker colors. And this is kind of a silly plot, but you can sort of make some ideas about cars here, right? Things that have less weight and less horsepower tend to be more fuel efficient, and these darker shapes tend to have more cylinders, and they're less fuel efficient and have higher horsepower and so on. So we're mapping properties of the data to the plot, and we can, and again, this is a multivariate space here. We're mapping 1, 2, 3, 4 variables here onto a 2D plot here, and we can start making some conclusions about the data here based upon how we represented things. One note here is we mapped the size property outside of the AES function. Okay, this parenthesis closes with this parenthesis here. So size is a mapped thing. Size is defined here, but it's not mapped in AES. And that's because here I just said, make the size 4. Make the size of the points 4. It's sort of an arbitrary scale, but it makes the size 4, a little bit bigger. This is outside of AES because we're not mapping the size to a specific column in our data. Okay, you only use those mappings when you're mapping aesthetics to columns in your data. If you're not doing that, you would pull size out of the AES function and give the explicit value that you wanted to supply. So let's imagine if you wanted to make all of the points red in your plot. that color would not go inside AES because we're not mapping the color to a column in our data. We were mapping the color to a specific value. You would pull this color aesthetic out and you would write it outside of that function. It would look something like this. Whoops. Color equals red. Okay. And you'd get rid of this part of the code there. Okay. So again, the AES is for mapping attributes or aesthetics of your geometric representation to columns in your data. Okay. That was a little complex. Any questions about that? Okay, let's take a look at some visual representations here about how you might want to think about and plot data.
Oh, yeah. Ryan, one question before you go. Can you just, can you just say, could you give one more example of how that would work where it's outside the AES?
Yeah, in fact, let me do this in our studio so we can actually take a look here. That would be better. Let's go find our studio. There you are. Hi, our studio. Okay, so first, got to make sure we load our TidyVerse. TidyVerse. Let's do this. Okay, and let's look at the output. It attached ggplot2 for us. Okay, so I mean, we could have done this as well. Frankly, we could have said library ggplot2. We would have just gotten the ggplot2 package. We wouldn't have gotten all the other stuff, but that would have worked as well. Okay, right. So let's take a look at this here. Goodness gracious. Let's take a look at this plot. Okay, so here's the plot here. Sorry, one other thing. In R, it's okay to use new lines, and a lot of times I use new lines a lot. You'll see lots of people do that, but this could also be backed up here if you want. Same thing, it won't affect it. Okay, so let's take a look at this color question. So again, we're mapping color to the miles per gallon. Hence, we got a gradient because it depends on the actual data points. But let's take that out. Actually, let's not do that. Let's do this. Let's take color out of the AES function call here, and let's put it here. Color equals red. And now all of our points will be red. So there's no gradients here because now we're mapping it to a single particular value. Where'd you go, plot? In any case, they're red now, and this has gone outside. And let's try doing this. Let's put MPG here, like we forgot to put this mapping. This mapping would need to go inside AES because we're mapping attributes to our data. Let's run this function here. What's going to happen? We get an error. I won't go into the error, but it didn't work because this needs to go inside of the AES function. That makes sense.
Yeah, thank you.
And just to be clear, we could map these things to anything. Let's map weight. Map weight again to color. That's kind of weird, but we should see a gradient across the x-axis here now. So we mapped both the x position and the color to weight. So now going across the x-axis, things will go from dark to lighter. Okay. Probably doesn't make sense to map the same data to different attributes, but there might be cases where that's useful to do. Okay, so great. One more thing here. Let me, while I'm here in the RStudio, let me not do the as.factor here on the shape cylinder, and let's see what happens in the code. So it didn't like it. Essentially, it says we're trying to map a continuous variable, which is cylinder, because it's a number, to a shape, which is a discrete value. Okay, so that's why we needed the as.factor converts a numerical representation into a categorical variable, which a shape is a categorical type of thing, not a numerical kind of thing. Okay. All right.
And I have a question.
Yeah, please.
And can you go back to our studio?
Yeah.
Basically, what I want to do is I want to put color equals MPG, and then color outside is red because I don't want blue color. Is it possible? So
great question. Yeah,
and also red color.
That's great. Okay, so this goes into a bit more complexities here. Yeah, and the answer to your question is right. This just talks about a mapping. Notice there's nothing about blue colors or green colors or red colors here. It just says map color to weight. We actually have to give another specification, which is a scale, a color scale that would apply to this mapping here. And we do scale, color, there's a couple ways to do it. I can follow up with you in more details, but you could do something like this, where is it red? Red? Do we have reds? Reds? There we go, reds. This is a color scale, okay? And so we got more, so now we have sort of a red gradient here. This is a more complex part of the ggplot2 template that we'll see later on. I'm not going to go into it in details, but you can define this color scale that you use in all kinds of flexible ways. Like, let's say, I don't expect anybody to understand this code right off the bat, but just let me show you this as an example. This is a spectral color scale that allows us to sort of get this heat map kind of representation now, where you know, higher weights are more red and you know, lower weights are more blue. So this is completely customizable, and you do that through a color scale.
Okay, thank you.
Okay, let's take a look at some different representations for data that we might want to use. Like I said, we can build up plots layer by layer using a plus sign. So let's take a look at some kind of cool, relatively complex features of the plot. Let's take our same weight versus or horsepower versus weight plot, but we're going to add on this GeomSmooth. This is a new geometric representation. It says, give us a smoothing line based upon the data that we're providing. Okay, and if we do this, actually this comes, okay, somebody had a question about sticking AES here versus inside the ggplot call. I'll show you that answer in just a second. Sorry, diversion. Let's get back to the plot here. When we add this additional layer here, we added a plus sign here and added a new geometric representation, GeomSmooth. We used the same X and Y representation here to tell it what it's going to do. And it drew this line for us, which is pretty cool. This is a smooth, I think a lowest smooth line here. And it can be did 95% confidence intervals on the line here. So it did all this sort of computation on the background, which was pretty cool. And all we had to do was just add another layer to our plot. Okay, so that's really powerful. We can also, let's say we wanted just a standard linear regression on this. We could supply another argument to this GeomSmooth function called method. And we're just going to do a simple linear model. And here it just did a straight linear fit to the data here. Again, with the 95% confidence intervals on the particular fit line that we could have had based upon the data. Okay, so and you could actually combine both of these. You could have added both of these things together. Well, let's take a look at that. Kind of funny, but let's go to RStudio. Let's get our plot here. We got this thing, right? Got our plot here. There's no reason. Well, yes, there's a reason, because it's kind of silly to do. I wouldn't do this in practice, but there's no reason we couldn't come here and add another layer on and do the one where we do the method equals LM, for example. Yep. Let's run this plot. Oh, okay, I'm sorry. It didn't work in this case because we already have a smooth layer defined. Sorry, I was trying to get a little too clever here. That didn't work. Sorry, AES. Oh, this had to be outside. Oh, good. I see. I got my own problem here. Remember the okay. This is what I had. This is a good error here. Let me try this. Method equals LM. This was an additional argument here, but we're not mapping this to our data. Okay, this was just like the color we had before. So we actually need to put this outside of our AES and put that here. Let's run this. Will this work? I've never done this before. Okay, it did work. It did work, right? There's no reason we couldn't have these two layers here. So we have both the original fit, the linear fit here, and then the other one here, and we layer these things together. This is a difficult plot to read. Don't make this in practice, but there's no reason why you can't do that. Okay. And again, the error that I made when I code is I put this thing inside of the AES command, but that's not the right place to put it. We're not mapping the method to a variable in our data. We're mapping it to a specific value. That's why it goes outside. Okay. But we could do this. We could say color equals red, and maybe this is a little more readable. So the linear, whoops, go back to RStudio here. The linear fit, where did you go? Plot zoom. The linear version is now in red, and the lowest smooth fit is in blue. Okay. Great. And we can just keep on adding layers and layers for different things. Okay.
Ryan,
yeah.
a question.
Yep.
So what's the first line here? The curved fit? Is that a piecewise regression?
This is a lowest smoothing function. How would you know that? How would you know that? Well, in R, you can do question mark GeomSmooth. Hit that, and you look at the documentation. You know, it'll tell you what's going on here. So it aids the eye in seeing patterns by looking for what blah, blah, you can read it here. But if you scroll down, sometimes these docs are kind of tedious to read through. They will tell you that tell you about the smoothing function. These are the different possible functions you can do. And there are some defaults that it uses here. So anyways, you'll just have to read through this. And it can tell you what's going on. Looks like, so it uses the lowest smoother if you have less than 1,000 observations. Otherwise, it uses this other one. So essentially, the idea here is take a look at the documentation because it can be kind of complex. Okay, and again, what I did there was I did question mark and the name of the function, and it gives the docs there. We could do that for geom_point too. Let's look at geom_point. For example, we might want to know the aesthetics that we can work with. It tells us here X and Y, color, fill, group, shape, anyways, all this kind of stuff. So the documents are useful. And because I'm not going into ggplot2 in completeness here, the documentation is going to be useful to look at. All right. Okay.
One of the questions, Ryan, is how do you change the color of the gray area?
Yeah, let's see here. So let's take a look. Come here. Good question. Let's try some things here. Fill equals red, and I'm just kind of trying to. Did that work? Okay, that worked. This has to do with kind of comes from like vector shapes and so on. Sometimes objects have things known as the stroke, which is the outline of the shape, and then the fill, which is the thing inside the shape. In this case, the confidence intervals can be colored by specifying the fill. Oh, okay. This is good. I just looked at an interesting thing when I wrote this code. Interestingly, I put this inside the AES function, okay? Really, you shouldn't have put it there. This should go outside. Let me save this because it's a good point here. It still worked though, right? We still got a plot out kind of like we expected, but not quite what we wanted. Because we were mapping the fill to a specific value, this should not go inside AES. And yet I did it there, and yet the plot worked. Let's run this plot. Okay. Let's see what happened with this one though. We stuck the fill inside of AES. It didn't give us an error, but it did something kind of weird. It mapped the color outside in this scale here. And that had to do with this automatic scaling legends, I should say, that ggplot2 does. Because this was inside of the AES function, it did this thing for you, and probably this is not what you want. Some details here that I don't have time to get into, but in any case, this would have been the way to do it. Stick the fill outside of the AES function because we're not mapping it to a column in our data table. Okay.
And then another question, Ryan, is how do you remove the gray, the grid lines gray in the background? Great,
that's a theming question. ggplot2 has a extensive theming infrastructure. I don't know how to say it. System. There we go. Extensive theming system, and there's all kinds of themes we can do. If you type, and again, we're going to add this on as a layer, so it's really cool. We can just put a plus sign, and we're going to go theme. And if you let the tab completion go through, you can see there's all kinds of built-in themes. You can make your own themes as you want. You can use themes here. Let's use theme minimal. Let's see what happens with that one. Oh, still has grid lines. Theme void. What does that do? Oh goodness, that got rid of like everything. Theme light. What's theme light? Anyways, you get the idea. There's ways to do it. We can also go into theme. It has an extensive way to modify these things. I think this is axis.ticks. Sorry, I don't expect anybody to, this is like detail kind of stuff, but just let me show you that it's possible. Axis.ticks equals elements, not ticks, axis, what is it called? Grid? Is it grid?
Grid lines, I think.
Grid dot axis.grid. There's a way to do it where anyway.
I think it panel grid major panel.
Thank you.
Grid.
It's panel. It's panel. Thank you. Thank you, Pablo. Okay, panel.grid. You can do it either on major, minor. You can do it major, minor, XY, all that stuff. Let's say panel grid equals elements blank. This is high level stuff. I don't expect anybody new to ggplot2 to understand this, except to say that there's an extensive theming system where you can control all aspects of this kind of stuff. Panel.grid.x is that panel.x.grid. Anyways, I'm fishing here, but in any case, it's all there and you can do it. There's, in fact, people have made themes like there's like an Excel theme. So if you like want to make like beautiful Excel theme charts, you can do that. If anybody reads the XKCD comics, there's like an XKCD theme where it puts like the sort of handwritten text and stuff. So like there's all kinds of stuff there. Just search it up, and there's lots of stuff with the theme. Okay, that was probably overkill there. In the interest of time, I'm going to push forward here a little bit. Let me answer that question that came up early about sticking AES inside of the geoms versus the main ggplot call. Notice here we had this code was duplicated, both in the geom point and the GeomSmooth. Duplication is not optimal. You don't like to repeat yourself. That's kind of a coding principle. What we can do is take this AES, stick it inside of the ggplot call as the second argument. Okay, so this goes in the main ggplot call. Now every geom that follows this will inherit this mapping. Okay, so we don't need to resupply it over and over again. This mapping will get essentially supplied to all these geoms. That doesn't mean if you wanted to change things up for some reason that you couldn't also supply a geom or a mapping inside of the geom that changes this specification in some way. You can definitely do that. But in any case, this helps you reduce code by sticking it in the main ggplot2 function call, ggplot function call. Okay, let me go through some quick examples here about ways to represent data. If you have one continuous variable, typically you want to look at the distribution of the continuous variable, and there's ways to do that. You can use histograms, so you can use geomhist to do that. You can use box plots. Box plots take something that goes along the x-axis that will group things in some way. So here we grouped by the cylinder, and then we looked at the distribution of weight by cylinder. That was a way to do that with box plots. If you have one categorical variable, you probably want a bar plot. And so you can use geombar to do that. Faceting here is really a powerful kind of thing. Let's take a look at this plot here. We mapped the shape of the points to the cylinder, whether it was 4, 6, or 8. This plot is a little bit busy, I would say. It's not, if you really look at it in detail, you can see there's some triangles here and some squares over here, but there's some circles here. It's maybe a little difficult to read. Let's look at another representation that might be easier to parse. We're going to use this idea of faceting. We're going to use this facet wrap layer. We just add on another kind of thing, just add a plus sign and a new facet wrap layer that says wrap these different plots in individual panels by the cylinder. Okay, there's some weird syntax here. There's a little squiggly line here. Yeah, sorry, that's just this syntax and you have to get used to it, but it exists. And look at what it did. It did something really kind of cool and powerful. It separated all the 4 cylinders out into its own plot, and 6 and 8 and so on. So now we can kind of maybe in certain circumstances, this kind of plot might be easier to read and interpret versus this particular plot. And all we had to do was just add another layer onto our plot. Didn't have to change extensive code, everywhere else. It was really simple and easy to do. Let's look at maybe a more polished plot here. Where
one of the questions we have is, what if I want to change the label of the legend as factor cylinder? How do I do that?
And these, I think we're probably talking about this 4, 6, and 8 here.
No, I think where you have on the first plot on the right-hand side, you have.
Oh, I'm sorry. That's really ugly, huh? Yeah. Okay. Let me do that. Let me pull this code here. And again, get into some of the details here, but that's great. That's what we're here for, our studio. Okay, let's get our plot here. Right. This is not, don't turn this plot in for your assignment. This is ugly. Like, you'd want to spell these things out. You'd want to make this a nicer label, certainly. So there's a couple things here. One thing to note is that this legend is getting automatically generated because we supplied a shape argument inside of our mapping. Okay, so it automatically makes this legend for us because of that. This is the scale. This is a shape scale. So we have to supply, if we want to modify what the scale looks like, we have to supply a new layer here called scale shape. And then the first argument we can supply here is the title that we want to appear here. So cylinder, C-Y-L-Y, cylinder. Did I spell that right? Cylinder. I'm not a great speller. Looks kind of right. Let's execute this code. So notice that now cylinder appears here in the legend, and we had to use a scale to do that, just to apply a new scale label here for this, okay? And that would have happened with the colors too. Let me get one of my color example here. Did I do, okay, yeah, I did that here. Actually, this one will work better. So I did a color scale here. And notice that the color was mapped to weight, but that's kind of ugly. So again, let's put weight here. I can spell that one right. Let's put weight there, run this code. And notice now weight has been updated here. It's not that ugly default thing. And then we can add another, add on our shape scale here, which defines how we're going to get that. And this is a slightly better plot now because now we have weight and cylinder that have been written out instead of the defaults. All right. Let me show you a little bit more along those lines here with this kind of plot here. What did we do here in this particular plot? We added a title and actually a subtitle here. We changed the theme. So it's not the dark gray background, but a light theme here. We actually put some alpha blending on the points here because we have some overlapping points, and you can kind of see it's darker when 2 points overlap versus when they don't. We added labels. This is, if you ever make a data visualization and you're going to turn it into your professor or your boss or whatever, always put labels on there. That's really important, unless sort of the label is implied by the title. So we added the labels with axes and added a little caption down here. We said the data is from the empty cars data set. So let's take a look at what this code looks like. In fact, let me pull this into our studio. And we can kind of walk through these pieces here. Oh, we'll get rid of this here. Okay, so here's our plot here that we saw on the slide here. Let's walk through this. ggplot on our empty cars. We have a lot of layers here, and I don't want to keep typing this mapping of X and Y. So I supplied that here in the main function call, so we don't have to keep typing that over and over again. We did a geom point. We set the colors to the steel blue size. We made the point size 4, and we set alpha blending. This is transparency. Think of alpha as transparency, and we dialed the transparency down a little bit. A transparency out of 1 is not transparent at all, and as you go down to 0, they get more transparent. So we dialed the transparency down a little bit. Notice these are not mapped to columns in our data, so these did not go inside of an AES function, right? These are outside. We added a smooth line here. The cool thing is because we faceted it, we got a smooth line, a separate and different smooth line for each facet variable. That's really cool. It did 3 calculations for us without us having to deal with that, just because we faceted the data. We updated the theme to this black and white theme, and then we added a bunch of labels on using this labs command, where we gave the title, the subtitle, the caption, and so on. So that's how we got this plot here. So we came out here, got this nicer looking plot that is more suitable for sharing with others. Okay, we're running up close to noon here. This is a more complex plotting template here that talks about geoms in terms of their different capabilities, coordinate functions, facet functions. Actually, there's scale functions on here that actually I didn't put. There's the gist of here is not necessarily to understand exactly what you see here, just noting that the template can get a lot more complex if you want to add more complexity to those plots. Check out the resources here. So on the last slide here, let me go here. This should be a clickable link. If I go in presentation mode, will it be clickable? It will. Okay. So these are the documentations for ggplot2. This is a little small. Let me zoom in. It's really long. Let me scroll through this. All kinds of geoms and scales and stuff, but it's kind of cool. You can kind of scan through here, and there are different pictures here for the different geometric representations. You can make lines and bars, and these are like cool little heat map grids, box plots and polygons, and distributions and dot plots and hexagons. You can make maps. This is kind of cool. There's a way to, like, if you want to make or the chloropleth maps or whatever, you can do that there. And the cool thing is, like, you can make a map and then like put points on top of the map just by adding a new point layer on top of a map layer. That's really cool. Lots of stuff there. So anyways, this is a great place to go to check out all the possibilities that you can do with ggplot2. If you want more information here, check out this great book, like I mentioned before, R for Data Science. Chapter 3 in particular talks about ggplot2, walks through some nice examples by the people that actually wrote the package, and has some really nice examples in code here that would be great to go through. This was Hadley's paper on ggplot2, and this is more recent. This didn't used to be the case. You had to buy the ggplot2 book if you wanted to read it, but now Hadley has put the next version online. So if you come here to ggplot2-book.org, you have the entire ggplot2 book, which is really cool. And you can go through and read this to your heart's content. That talks about lots of the things that we talked about in the presentation.